Welcome again everyone. In this video I'll be making a more complex mold for high volume production. As you can see, there's the top and the drag of the pattern, both connected to a board, and both have an interlocking running system when you flip the board upside down. It is intended for high volume production, so let's start. First thing we need to do is take the crown and select an appropriate sized box. The crown's lateral movements are painfully slow, but it is for everyone's safety. I have selected the square boxes which perfectly fit the boards of the pattern, and they also have trunnions. Trunnions are these rounded bars on the corners of the box, and they are very helpful when you need to flip the box. I guess another name would be pivot points. I leave the boxes by attaching the chain to the opposing corner trunnions. That way I can lift them and manipulate them without them actually rotating or falling. The holes you can see are located on both sides of the box, and they are pinholes through which you put a metal rod, a pin, and they help removing lateral movements when closing or opening the box, and generally just guiding. On the sides you can see dovetail flanges, and they are really helpful when you close the mold. Once again, they are a necessity when it comes to casting success rates. If clamped properly, the mold will not open and the metal will not spill and waste a lot of sand and time. There we go, easy does it, nice and gentle. I do not want to hit the wooden pattern with a heavy metal box. The damage would be substantial and the pattern maker would not like me that day. Well, he doesn't like anyone. Anyhow, I'm rotating the box here because I do not want any flanges to stick out where the pouring side will be. I mean, you can see that rectangle piece of wood on the pattern. That's where the down pin will be, and that's where the metal will be poured, so you want the crucible to be able to reach as close as possible to the sides of the box. As the depth of the box is sufficient to cover at least 2 inches above the drag, I mean the bottom of the pattern, so I will relocate the top box onto the next board. Same way, nice and slow, easy does it. When I said 2 inches, I meant the minimum clearance between the top of the pattern and the top of the box should be at least 2 inches. Otherwise the structural integrity is compromised. As always, for the top I take sleeves of predetermined width and place them where they should be, 2-inch neck downs, 1.5-inch opens, and 4 1-inch opens for the side flanges. For first time viewers, these ceramic sleeves help feeding the casting. They're of various sizes and they create pressure by Bernoulli's effect, and they make sure that the casting is completely filled before it starts to solidify, and they will also take the damage. And that's where the location of the down pin is. I've just placed it on one of the running bars. First the metal will be poured where this taper down pin is, and then it's going to fill up the running bar, which you can see as a rectangular piece on which the down pin sits. And then the metal will fall and fill out the drag's running bar. In this case, it is perpendicular to the top's running bar. And then it's going to fill the casting bottom to top. As per usual, it's time to powder the patterns so that the sand doesn't stick to the pattern or to the board below. The next step is obviously to fill the boxes with sand. I'm using a wheelbarrow. Using is a big word for me. I'm using a wheelbarrow because it just makes life simpler, and in one go I can carry a lot more sand than by using buckets. And with a click of a green button, here comes the premixed sand. Now it's very important that you do things accurately and quickly from now on, because any mistake can lead to a discarded wheelbarrow full of sand, and that's quite a lot of waste of both the sand and the epoxy. Once the wheelbarrow is full, I give it a gentle shake to set the peak so nothing is over, and we go back straight to the workplace. I've lost some footage. You can see other halves and tops already being made, but hey. Instead of using hands, I use a shovel to empty the sand into the box, and I drop it from a height so that it fills out all the cracks and crevices of the mold. You saw that the pattern had quite a lot of features which are tricky, and I will pay special attention to them, but first we need to fill it up. And on to the good old thruster rammer, paying special attention to the sides and the corner of the boxes and specific features of the pattern. It is important to remember what the pattern looks like and how it is located within the box. You do not want to hit one of the features and damage the pattern. And straight back to the shovel. As you can see, it's quite a straightforward operation, but you really need to pay attention that you filled up all the voids, all the cracks, all the corners before you add another layer of sand, because once it sets, that's it, that's game over. And you either end up with voids and defects in casting, or a whole load of sand being wasted and tossed into the skip. Spread the sand around so that it's nice and even in thickness. If one part is thin and another part is thick, ramming with the equal pressure will not create equal results. What I mean is that if you have a thick layer of fresh sand, and if you ram it, the bottom will not get upset and it will not really move and fill up the voids. As you can see, this is quite a laborious job. Doing this for 8 hours straight will get you jacked up. Not really, I'm still 120 pounds cunt. Ready for a round 2. Another wheelbarrow full of sand.
GoPro, stop recording.
And straight back to my workstation. In this case, I'm being very general with the amount of sand because I've already covered the pattern up, so now it's just a matter of filling the top of the box. And there's always somebody stealing your nice fresh sand. Bastards. Who needs CrossFit? Who needs a gym?
I got it on video,
I can work all day and get covered with cream. I get paid by the hour, I get a bonus for the mold. Bosses are happy if I do what I'm told. My mama says she's proud. I don't know if it's true. All I know is 40 time I drink iron brew. I guess metal fume fever hits hard. There I go, I'm almost done with the ramming. And then I'll transfer to a flat rammer. But not before I smooth out the surface, to see if I need more sand or not once I level it. Yep, I could use a bit more sand. So that's what I do, I'll just add more sand. This is my favorite method. Tip it all over, works every time. I am making it even again, no high spots, no low spots. As long as I can get it nice and level, it's fine. And then I powder it to prevent the sand from sticking to the flat rammer. And then I flat ram it. I compact the sand below and make it stick took the pattern if it already didn't, and compacting it makes it so much stronger. It resists the pressures of the metal. This is one of my favorite parts. Really, it's quite therapeutic. It feeds my OCD. You can actually feel the sand stop giving in once it gets compact. It becomes much harder. Next, I scrape the extra sand. It's way too off to be used already. It's been sitting in that barrel for a while, so I guess I'll just throw it away. Here I'm fixing a dimple of some sort. I just work backward and forward and ram it with the scraper, and then I scrape off the extra, and there's no more dimple. Magic. The point of this video is to show how long it actually takes to make a mold. It's not a 1 to 3 process. It's quite laborious and time consuming. Once the sand is set, I rotate the molds and I use wedges to remove the board and the pattern. A very slow and precise, delicate operation. I'm hammering several wedges at a time, little by little. If I were to use just one wedge and just hammer it straight in, it would bend the bottom board and the pattern and break off the sand or the pattern. So little by little, just like that. And once I feel it's loose, I try to tilt the board left and right while pulling it straight up. Since I was rushing a little bit to pull the board up, I developed a big crack and a piece broke off, but it was very easy to glue back together. If it was a small piece, I would either fill it up with sand or just leave it as is, but this was a very easy fix. Not recommended. Once I fix that, it's time to apply the zirconium refractory paint. And then to set it by burning the isopropanol off using a propane torch. This is a very fun part. Next I head to the core maker table and I pick up my cores. On the table you can see left and right parts of the cores, and they have to be glued together using a special glue and then painted in this red refractory paint. It's a little bit lighter, so easier to apply. It's dipped instead of brushed. You can see the parting line of the core. Next I take the cores and I fit them into the mold. First I need to figure out how they go in. And then I rub them into the mold so that a perfect fit is achieved and there is reduced flashing of the metal. You want the mold halves to close perfectly and remove all unnecessary space. Unfortunately, I lost footage of sealing and closing the mold. So here's the pouring process of a similar mold. However, it's the same metal, so the same casting process. It's the SG cast iron. Anyway, thank you for watching my videos. Please like them, comment them, and subscribe to my channel.